Hi all. So next topic is time response analysis. That's from second module. The first step in the control system analysis and design is to formulate a mathematical model. But in practice, the input signal to a control system, it is not known ahead of time, but it is random in nature. So here what we have to do is, that is, in analyzing and designing the control system, we must have a basis of comparison of performance of various control systems. That is, we must have a basis of comparison. That means if the system is working satisfactorily for some standard input signals like step, ramp, parabolic, etc., then it is assumed that it will work satisfactorily for actual input also. So here we must have a basis of comparisons of performance of various control systems. So standard input signals are step, ramp, parabolic in the case of time domain analysis. In the case of frequency domain, sinusoidal signal. We can analyze the response of the control system in time domain and also in frequency domain. And what is time response? The response of the system with respect to time. The response of the system C of t with respect to time, it is called time response. It has got two parts, transient part and steady state part. And again, what is transient response? Transient response, it is the by transient response we mean that which goes from initial state to the final state, which goes from initial state to the final state. That is transient response. Now steady state response. Now steady state response. That is the manner in which the system behaves as time t tends to infinity. So time response, it has got two parts, transient part and steady state part. Mathematically like this, C of t is equal to, this is transient part and this is the steady state part. It can be expressed like this. So the transient response, it is which goes from initial state to final state. And steady state response, it is the manner in which the system output behaves as time t approaches infinity. So this is an example, C of t. The output is equal to 20 plus 10 e raised to minus t. 10 e raised to minus t, it is the transient part. When time t tends to infinity, this will become 0. So this is transient term. And the first term, this 20, it remains there even when time t approaches infinity. So this 20 is the steady state term. Now the standard input signals are step, ramp, parabolic, impulse, etc. Unit step signal, as we all know, it is when time t greater than or equal to 0, it has got a value, it has a value of 1, equal to 0 for t less than 0. And it is represented like this, and its Laplace transform is 1 by s. For unit ramp signal, r of t is equal to t for t greater than or equal to 0 when t less than 0. And its Laplace transform is 1 by s square. Parabolic, when t greater than or equal to 0, the value is t square by 2, and t less than 0, the value is 0, and the Laplace transform is 1 by s cube. Now unit impulse signal, its value, when time t is equal to 0, it has got infinite value, and when for all other values of t, it has got, the signal is 0. But in actual practice, it is usually approximated by a pulse of small width but unit area, and its Laplace transform is equal to 1. Now we have to study the time response of the first order system. Before that, we have to familiarize with the two terms, open loop transfer function and feed forward transfer function. And what is open loop transfer function? Open loop transfer function, it is the ratio of feedback, it is the ratio of feedback signal B of s to the error signal B of s by B of s by E of s. The ratio of feedback signal to the error signal B of s by E of s. Now what is B of s is equal to, from this figure, B of s divided by C of s, that is equal to H of s. And what is E of s? E of s, C of s by E of s, that is equal to G of s. That is from this individual transfer function. G of s is equal to C of s by E of s. So G of s is equal to C of s by E of s, and H of s is equal to B of s by C of s. So B of s is equal to C of s H of s, and E of s is equal to C of s by G of s. That's equal to G of s H of s. It is known as open loop transfer function, G of s H of s. Now feed forward transfer function. It is the ratio of the output signal C of s to the actuating signal E of s. It is called feed forward transfer function. So Cs by E of s, that is equal to G of s. So this is known as this G of s. It is known as feed forward transfer function. Feed forward transfer function. So open loop transfer function, it is Gs Hs. If unity feedback, then H of s is equal to 1. Then open loop transfer function is G of s. Okay. Now, we have to find the time response of first order system, second order system, etc. First order system and second order system with for unit step input. Before that, what is order of a system? The highest power of s in the denominator of the transfer function is called order of the system. The highest power of s in the denominator of the transfer function. Denominator of the transfer function equated to 0, it is called characteristic equation that we already studied. Okay. Now consider this block diagram. In this forward path, let the transfer function is 1 by st. So Cs by Rs is equal to, by using this formula, G of s divided by 1 plus Gs Hs. Hs is equal to 1 in this case. G of s is equal to 1 by st. Hs is equal to 1. And simplifying, we will get Cs by Rs is equal to 1 by 1 plus Ts. Hence, the above transfunction, this transfunction is is of the first order, and the system is said to be first order system. This is 1 plus Ts. The highest power is 1. Therefore, it is a first order system, and it is called first order system. And example is an RC circuit. We already derived the transfer function for an RC circuit, electrical circuit, and it is transfer function is 1 by 1 plus RCS. So this RC, that's equal to time constant T. So 1 by 1 plus Ts. So RC circuit is an example for a first order system. Now, our aim is to find the step response of a first order system. Our aim is to find the step response of a first order system. What do you mean by step response? The response of the system with input with the unit step input. The input is unit step input. At that time, what will be the output? That response is known as step response. Input is step input. The response of the system when the input is step. So step response of first order system. Consider a unit signal, step signal as an input. So R of t is equal to step inputs. Therefore, R of s is equal to 1 by s. Consider the equation C of s is equal to the transfer function Cs by Rs is equal to 1 by 1 plus Ts. The right Cs is equal to, because our aim is to find the response, that is C of t. So write C of s is equal to. Now substitute R of s is equal to 1 by s in this equation. So C of s is equal to 1 by 1 plus Ts into 1 by s. Rs is equal to 1 by s, step input. So this is equal to 1 by s into 1 plus Ts. Now take the partial fraction a by s plus b by 1 plus Ts in order to get C of t. Our aim is to get the response. So C of t. So take the partial fraction, and a is equal to 1 and b is equal to minus t, and therefore C of s is equal to 1 by s minus t by 1 plus Ts. That's equal to 1 by s minus 1 by s plus 1 by t. take t outside, that t and this t, it will get cancelled in order to make it in a standard form. So we can take the inverse Laplace transform. C of t is equal, in order to get C of t, that's equal to 1 minus e raised to minus t by capital T u of t. So the output rise exponentially from zero value to a final value of unity. Final value step input, therefore final value is step input, therefore the final value is unity 1. This t is known as time constant. Time constant is indicative of how fast the system tends to reach the final value. Smaller the time constant, faster will be the system response. Smaller the time constant, faster will be the response. Now we can see in the response is C of t is equal to 1 minus e raised to minus t by t. It has got two parts. Transient part is e raised to minus t by t, and steady state is what? Finally it attained. So when time t tends to infinity, this term will become 0, and the final value is equal to 1. That means it attained the final value of 1, because the input is step input. Therefore, the final value is 1. So it is gradually increasing from 0. Finally, it reaches to 1 in steady state. So the steady state value depends on the magnitude of the input. If it is equal to 1, it is 1. If it is 5, then it will be 5. Now, the error. The error is given by E of t is equal to R of t minus C of t. C of t is the actual output. R of t is the reference input. Reference input is the desired output. R of t is the reference input. Reference input is the desired output. So, the difference between these two, that is the desired output and the actual output, that is the error. The desired output, the input to the system is step input. So the desired output, that is the reference input, that is equal to 1 minus this output of first order system, that is 1 minus e raised to minus t by t, that's equal to e raised to minus t by t. Then when time t tends to infinity, that is the steady state error, ESS. It is denoted by ESS, steady state error. When time t tends to infinity, this term will become 0. That is, finally it approaches the steady state value of 1. There is no error at a steady state or when time t tends to infinity. So remember this equation. Error is given by the difference between the reference input and the actual output. Reference input is the desired output. So the difference between the desired output and the actual output is the error. Here the reference input or the desired output is equal to 1, and the response of the first order system is this. So when time t tends to infinity, this term will become 0. That means steady state error is equal to 0. Thank you.